All right, here we are with special products with me, Mr. Hain. And our essential question for this section of the video is, how does multiplying polynomials help me multiply special products, which is our topic for today. Let's dive right in with a quick review of how we multiply binomials. So I use the seashell method. That's, I don't know, copyright pending me. I have no idea. But what I do is I take the first term in the first group and I multiply it times the first and second term of the second binomial. And so I have x times x and x times 4, and that of course is x squared and 4x. So x squared plus 4x. Then I take the second term in the first group and I multiply it times the others in the second binomial. So I have 3 times x and 3 times 4, and of course that gives me plus 3x plus 12. Combine those two middle terms, and I have x squared plus 7x plus 12. Kaboom! So slightly more complicated, I'm going to look at example 2, and I'm going to multiply the 3x by the 5x and the negative 3. Color coding all the way this time. I've got 15x squared, that's 3x times 5x, and minus 9x, that's 3x times negative 3. And then I've got 4 times 5x, which is 20, and 4 times negative 3, which is negative 12. I'm going to, again, combine those middle terms, and I have 15x plus 11x, 15x squared plus 11x minus 12. All right, go ahead and try checkpoint 1 and checkpoint 2. Pause the video. The solutions are not there, but work them out the same way that we did example 1 and 2. I'll be here when you get back. And we're back. So the title says multiply unusual binomials. I say this is unusual only because the x's are the second term in each binomial, and they are both negative. Same rules apply. Gonna multiply the exact same way. 2 times 3 is 6. 2 times negative 4 is negative 8x. Negative 5x times 3 is negative 15x. Negative 5x times negative 4x is 20x squared. We like to order our multi-term polynomials in descending order of their exponents. So I'm going to combine these middle terms and then write it as 20x squared minus 23x plus 6. Go ahead and try checkpoint 3. It's done the same way that we did our example. There is no solution, but I'll be here when you get back after you pause the video. And we're back. Okay, cool. So here you see that this is only a product or sum or difference of two terms. So I have the exact same terms inside of each binomial, but one is addition and the other is subtraction. So let's see what that does for us. So when I multiply, I'm going to multiply everything out, and you'll notice that the two middle terms, negative 12y and positive 12y, they cancel. And they always cancel when it's a difference of binomials. So I'll get 16y squared minus 9, and that's it. Now that's the shortcut, so I can go ahead and take a look at this. 3x times 3x is 9x squared. 7 times 7 is 49. I just have to multiply those, and it's subtraction. 9x squared minus 49. Why? Because the middle terms will always cancel when the only difference between the two binomials is addition and subtraction. Boom. Let's take a look at example C. And the exact same thing is true here. Don't let the 8 to the 4th trip you out or fool you. You're still just multiplying the first with the first and the last with the last, because those middle terms will cancel when you're talking about a difference of binomials. All right. Sorry for the bad singing, ladies and gentlemen, but it's 25a to the 8th minus 36. Kaboom! Go ahead and do checkpoint 4's examples the exact same way that we did example 4. Pause the video. I'll be here when you get back. All right, let's square some binomial sums for example 5. So squaring means, of course, I'm going to multiply both of them, the same term, the same binomial, by itself. And so when I do that, I square. So x times x is x squared. X times 3 is 3x. Then the second 3 multiplied by the first x, of course, is going to be 3x. And then 3 times 3 is 9. So they will always be 2 times a, b. 2 times a times b, where a is the first term and b is the second term. Okay, and that's kind of weird to look at, but it'll always turn into a squared plus 2ab plus b squared. or x squared plus 6x plus 9. So what this means is that you see that in our final answer, which is here in black, if I take the original problem, the first term is x. X times x is x squared. That's a squared, x squared. You'll see that 2 times a times b just basically means I'm going to take the first term and the second term and multiply them together. X times 3 is 3x. And then the rule says it's always going to be twice that. So 3x times 2 is 6x, and we see that here. The last term is b squared. So you see I have 3, which is my b term in this square of a binomial. So I have 3 times 3, which is 9. Awesome. This is always true and will work out and help with example B. So let's check it out. I take example B. I know that A is 3x and B is 7. So the shortcut here says 2 times A times B. So A in this binomial sum is 3x. B is 7. So 3x times 7 is 21. 21 times 2 is 42. And that's why I have 9x squared plus 42x plus 49. Of course, 3x times 3x is 9x squared, and 7 times 7 is 49. Okay, so deep breath, rewind it back, take a listen again. I'm going to, as I go through it slowly. But if this is super duper confusing to you, do not worry. Go ahead and just write it out like we did here, and then work it out using the seashell method, and you'll always get the right answer. This is just a shortcut, and if you see it, it can help you in your thinking as you start seeing over and over again that this is a shortcut that you can take. So regardless if you use the shortcut or not, go ahead and pause the video, work out checkpoint 5, A and B, the same way that we worked out our examples. Whether it be with the shortcut or whether it be with the seashell, it does not make a difference to me. I'll be here when you get back. You got this. And we're back. So for example 6, for example 5, we talked about a binomial sum. So for example 6, we're going to talk about a binomial difference. So the same thing applies when when the binomial is a minus b squared. So the only difference, as you see in my shortcut, I have minus 2ab. So in the previous slide where it was a binomial sum, you see that I have a squared plus 2ab plus b squared. So it's plus 2ab. When we're doing the difference, it's minus 2ab. Okay, cool. So I know a is x and b is 4. So 2ab is 2 times 4x, and of course that's x squared minus 8x plus 16. And again, like if you don't like this or this feels uncomfortable, don't worry. Stop. Just seashell and combine the middle terms, you'll be fine. It's just that these middle terms are always minus 2ab. So a being the first term in the binomial, b being the second term in the binomial. Multiply those together, as we see here, times 2. And we're going to subtract. Boom. If you see it, you see it. If you don't, use the seashell. Cool. So let's go ahead and take a look at example 6b. Same thing, going to use the shortcut. I see a is 5y and b is 6. So 25y squared minus 2 times 6 times 5y plus 36. And of course, 5 times 6 is 30y, so 30y times 2 is 60y. So 25y squared minus 60y plus 36. Again, if you see the shortcut, want to practice the shortcut, use the shortcut. If you don't and it confuses you, just seashell. You'll be fine. Go ahead and pause the video, work out checkpoint 6AB. I'll be here when you get back. All right, now our next section of the video is dividing polynomials with me, Mr. Hain. And our essential question for this section of the video is, how does subtraction help me understand dividing polynomials? Okay, so this is a lot easier than our previous sections where we're multiplying binomials or multiplying exponents. Here we're just going to be dividing. It's straightforward. So in dividing, here we see 2 to the 8th divided by 2 to the 4th. Really what that means is I have 2 times itself 8 times, and then I have 2 times itself 4 times. And when I expand it all the way out, you see that all I am really going to be doing is canceling 4 of those 2's because they match in the numerator and the denominator. What does that mean? That really means all I'm doing is subtracting. 2 to the 8 minus 4. 8 minus 4 is 4. And it's that simple. If we look at b, I'm just going to be subtracting. 13 minus 3. So when dividing exponents with the same base, we subtract the exponent. So let's take a look at example b. Boom. 13 minus 3. X equals 10. And for example C, I'm going to do the same thing. When dividing exponents with the same base, subtract the exponents. Yo, Mr. Hayne, there is no exponent here. When there is no exponent, the exponent is, if you said 1, you've been paying attention. So 15 minus 1 is 14. No problem, y to the 14th. Go ahead and do the exact same thing with checkpoint 1, A, B, and C. Pause the video. I'll be here when you get back. And we're back. Okay, cool. So any number or group term to the 0 power equals 1. All right, so that means 7 to the 0, 0. Here's a group term, so negative 5, quantity negative 5 to the 0, 1. Here's another group term in E, that's 10x, or 10 times x to the 0 equals 1. All right, that leaves us with C and D. So let's take a look at what's happening. So with, believe it or not, this here is actually a product. It is negative 1 times 5 to the 0 power. So the 5 is the only one being raised to the 0 power. And we know anything to the 0 power equals 1. So that turns into negative 1 times 1, or just negative 1. And so for example D, the only term that's being raised to the 0 power is x. And that means we have 10 times x to the 0, or 10 times 1. And because we have 10 times 1, 10x to the 0 is just 10. So go ahead and pause the video, work out checkpoint 2 the exact same way that these examples are worked out for you. I'll be here when you get back. So now we're going to take quotients and raise them to a power. So remember, when you take a power of a power, all you do is multiply the exponents. And for example A, there are no exponents. And when there are no exponents, the exponents are 1. So there you go. X squared over 4 squared. Of course, it's such an easy thing, 4 squared. I'm just going to write x squared over 16. That's simplifying it all the way. So when I take a look at example B, I'm going to multiply the exponents, and the exponents here is there for the x term is 2. It's squared. So I've got x to the 2 times 3 over 5 to the 1 times 3. That's x to the 6th over 125, because 5 times 5 times 5, 125. All right, so a complex quotient to a power, I'm just going to multiply them out. So I've got 2 to the 1 times 5, a to the 3 times 5, b to the 4 times 5. Simple multiplication. 2 to the 5th is equal a to the 2 to the 5th times a to the 15 over b to the 20, and I know 2 to the 5th is 32. So go ahead and work out checkpoint 3 the same way that we worked out example 3, and I'll be here when you get back. So we're going to build towards dividing polynomials, but first we're going to divide monomials. So for example 4, I want to just break apart what is happening. So let's take a real close look at example A. And I've circled the negative 12 and the 4 because we're going to divide those numbers. So the most common mistake that I see is that students start getting into this and they're like, oh, okay, so we're subtracting the exponents. So what I got to do is subtract the numbers. No, don't forget how to divide, ladies and gentlemen. It's negative 12 divided by 4, which we know is negative 3. And then we know x to the 8th divided by x squared is x to the 8 minus 2, which is x to the 6th. So the answer for A is negative 3x to the 6th. So all I'm doing is dividing or simplifying the numbers and dividing or simplifying the exponents with the same base. Kaboom. I have 2/8, and I can reduce that fraction, and I've got x to the 3 minus 3, which is x to the 0. Well, that's 1. So now I have 2/8 times 1. And of course, that's 1/4 because 2/8 reduces to 1/4. Sweet. If we look at example C, we're going to do each part. 15 divided by 3, 5. X to the 5th divided by x squared, x to the 3rd. Y to the 4th divided by y, y to the 3rd. So we're just combining what we did on the first slide for dividing monomials or dividing polynomials in the second section of this video, and we're doing it multiple times in the same term. because it's monomials. So go ahead and pause the video for checkpoint 4. Do A, B, and C. I'll be here when you get back. As difficult as I can make it, let's divide a polynomial by a monomial. So there's two ways I can present it, either example 5 or example 6, but I solve them the exact same way. So I'm going to take the first term, which is negative 12x to the 8th, x to the 8th, and I'm going to divide it by 4x squared. I'm going to do that with each of the other terms in the polynomial. So this is exactly the same thing that we did in the previous slide, only now we're doing it to multiple terms in the same problem. That's the only difference. Boom. So negative 12 divided by 4 is negative 3, x to the 8th divided by x squared, x to the 6th. And you see each of the terms simplifies to something without a denominator. So now I just have a polynomial, negative 3x to the 6th plus x to the 4th minus 2x. Kaboom. Example 6 is even easier because what example 6 does is it already reminds us that that 2x to the 3rd is dividing each term. So as I divide each term, I divide the numbers, then I divide the exponents, and I've got my answer. So for the second term, I can't divide 9 by 2, so I just leave it as a fraction. Fractions are numbers too. Fractions are friends, not food. Okay, sorry, quoting Pixar. But that is exactly true. Go ahead and don't be afraid of fractions. They are awesome ways to express some really complicated decimals. So go ahead and do checkpoint 5 and checkpoint 6 the same way that we did example 5 and example 6. Pause the video. I'll be here when you get back. And ladies and gentlemen, that's it for today. But until next time, keep doing the math.